Okay, guys, here's a method for graphing a cycle of a trig function that has a change in phase shift and maybe is shifted up or down or something like that. The way that our pre-calc book teaches is that you actually use the endpoints of one cycle. So whatever trig function is, so if it's sine or cosine, one cycle would happen between 0 and 2 pi, certainly in other places, but that's the easiest place to use. So what we do is we can find the endpoints of a cycle that it'll adjust the endpoints for us according to this method so that you can graph one cycle and know exactly where the cycle begins and ends. And it's just a lot easier than factoring in the phase shift and stuff like that. So the method is you take whatever's on the inside here and you're going to sandwich it between the endpoints of one normal cycle. So for sine or cosine, again, the endpoints would be between 0 and 2 pi. For different trig functions, you have to look for where a cycle happens, so it obviously is different for the various trig functions. And then as long as you put your endpoints of one cycle for the unshifted normal trig function, the parent function, so here is sine, then you just solve so that you have x in the middle. Okay, so I'm showing all of my steps, but let me try and hurry up here. So I've got 9 pi over 4 on the right, and the last thing is I have to get rid of the 2/3, so I multiply all the pieces by the reciprocal. If you have to multiply by negative, of course all the inequalities would flip, but that's not happening here. So I have 3 pi over 8 is where one cycle begins for this graph, and 27 pi over 8. So the numbers might look ugly, but the method makes it pretty simple to do it despite ugly numbers. So basically what that means is when I go to graph this function, okay, mark wherever you want 3 pi over 8 to be, a cycle begins there and it ends at 27 pi over 8. So the idea is that this is what, -5 sine, so sine is being flipped upside down, so the graph's going to look like one cycle of it like this, right? And the amplitude would be 5. Whoops. And it goes down to -5, so it was flipped upside down. And then you're probably asked to label the 5 key points. So for example, what is this mark in the middle? Well, that's the middle of 3 pi over 8 and 27 pi over 8. So you find the middle of any two numbers by adding them together and dividing by 2. Or you could have broke this down into like pi over 8, 2 pi over 8, 3 pi over 8, and so on. It's just annoying that it goes all the way up to 27. I think this will be faster. So you get 30 pi over 8 over 2. So this is 30 pi over 16, and I'll reduce it. So what, 15 pi over 8 is the middle, which makes sense. That seems reasonable. Okay, to get the 5 key points, there's 3 of them. And then I would need to know the minimum and the maximum. So this key point goes up to 5, this one goes down to -5, but I need the x values, of course. Okay, so you can find what's in the middle of 3 pi over 8, 15 pi over 8. So I'm not really trying to waste a bunch of time showing this, but in case if a student's watching this, I'll go ahead and do it. Okay, so what's in the middle right there? So that would be 9 pi over 8. So there's another key point right there. And then to get this maximum, that key point, I'd be finding the middle of 15 pi over 8 and 27 pi over 8. Oh, I have to divide by 2, sorry. Oh, I'm going to reduce the top already. So 21 pi over 8. And there it is, really painless. If the graph had been shifted up or down, so let's zoom out and just quickly talk about what if it had been y equals -5 sine of, same thing, 2/3 x minus pi over 4 plus 2. Well, it's going to be exactly the same except the midline, the middle of the graph, shifted up 2. So I'm going to zoom out a lot, but I'm going to just quickly show you. Okay, so same exact thing except the middle, instead of being on the x-axis, the middle is now going to be at 2. Which means it's going to go up to just add 7 to the max height. Sorry, add 2 to the max height to get 7, and then add 2 to the bottom, so that'll be at -3. And then it's the exact same thing. So, let's see. It begins and ends on the midline, a sine curve does. It passes through the midline exactly halfway through. It hits its minimum point, well, when it's flipped upside down, the minimum would occur first instead of at the beginning. And that would be exactly halfway through, which was, I can't hardly read that, 9 pi over 8. Okay, so it reaches the -3 at that x value, so that would be right there. And then it reaches its maximum at 21 pi over 8, which would be a maximum of 7 there, and then just connect your dots. And this method would work for any trig function. You just need the endpoints of the cycle. Be careful what function you're working with.